Next up, we are going to hear from GS Biomats, commercializing sustainable furan bio-based materials. Delighted to welcome their Global Marketing Director, Susan Zhu. Susan.
There is no screen here. Oh, it's here. Okay, thank you. Okay. So good morning, everyone. It's my honor to be here to present our company. We're based in China. Our company, the name is GS Biomats. Also, the full name, the Chinese name is Zhongke Guosheng. I'm Susan Zhu, and I'm the Global Marketing Director. It's also my first time to USA as well. So thank you all. Before we dive into details about our company, let's look into our technology road, what is our main product. So by comparison to petroleum-based industry, they have benzene and we have HMF as a bio-based platform compound. And then from HMF, we generate bio-based monomers such as FDCA and other valuable monomers as well. But at the moment, FDCA is one of the most important downstream monomers of HMF. And then by downstream of FDCA, by combining with MEG, we got PEF and other products as well. So that's what we do. Produce, commercialization, and exploring the technology of HMF and FDCA. So our company, we set up back in 2021, and we have our headquarters in Zhejiang province. It's like 1 hour trip from Shanghai. And we have a pilot plant. The pilot plant is located in another city in Zhejiang province as well. And we have our commercial plant, which is under construction at the moment. Details about the commercial plant and the pilot plant I will explain in my later slides. And the key technology about our FDCA and how we do several key upgrades. So what is the uniqueness about our technology and how we generate high purified FDCA from HMF? Upstream feedstock, biomass feedstock, at the moment, we are using the commercial sugar directly from the market, which is generated from corn, and then from a mixed syrup of glucose and fructose. And then directly, we generate crude HMF, which is low-concentrated HMF solution. And from that low-concentrated HMF solution, we generate FDCA and other monomers directly, which I'm showing here a crystal HMF solid, because based on our current understanding, majority of our counterparts, if they are using HMF to generate FDCA, then first step, they need to purify HMF. But our technology, we can use crude HMF directly to generate FDCA, which we call it a shortened solution from HMF to FDCA, which has largely reduced the cost and energy and time about the whole process. And the second generation of biomass feedstock, such as sugarcane or sweet beets, those kind of technology, we already have it in our lab. But when to commercialize it, we really need to see how the market reacts to it. And also, the third generation of biomass feedstock, such as biomass waste, we are also developing in our lab at the moment. The technology we are using at the moment, one is our shortened technology, which I mentioned before, from crude HMF directly to FDCA, because crystal HMF is very sensitive to air and water, so you need low temperature storage, you need cold chain delivery, all that adds up to the cost. But our shortened solution, which has efficiently improved the efficiency and reduce the cost. That is one part of our technology. And the second part is that we use continuous production process for both HMF and FDCA. We do not use the reaction batch, one batch to another, but we're doing it in a continuous pipeline reactor, which we use our self-invented catalyst to make sure that this reaction can be running smoothly for a long period of time in the pipeline reactor. That is our key technology know-how. And this is the road we have gone through since 2021. We have gone through several major quality improvements for both FDCA and PEF. The quality, the color of the shape of FDCA has been improved significantly. And accordingly, the color of PEF has also been improved a lot. Back then, we were thought maybe the yellowish is the original color of PEF, but after several years exploring, we think, yes, we can produce PEF as transparency as PET. And in the past years, we have also finished several key regulations or registrations. One is we have got the USDA approval for the FDCA, which is 100% bio-based. And also we have finished the full registration for new chemicals in China. We are currently the only one who have finished this kind of registration in China. And also we have finished the REACH registration as well. And recently we just, through authorized the third party, we finished our LCA report for FDCA. So by comparison, FDCA to PTA, the greenhouse gas emission has been reduced by 24%. So on that side, basically we have done a lot for the regulation and the registration. So I think next step, we need to go further down to the downstream, such as food contact material approval also. And then when talking about end-of-life solution, here is just one very simple task we have done together with our downstream partners. So by comparison, the PET fiber, chemical recycling of PET fiber and PEF fiber. So we do the chemical depolymerization of PEF, we got FDME. And by comparison to PET fiber, the yield in the lab is 52%. The industrial yield we haven't tried yet, but we are planning to do it very soon. But what's more importantly is the purity of the monomer we recycled, FDME, can reach to 94% and above. Regarding our production capacity, we have the pilot plant, which has been running smoothly and stably for more than 2.5 years. And during the past two and a half years, we have successfully delivered more than 200 metric tons of products to the world, to our downstream partners to do research. And based on the customer feedback, they are quite satisfied with the capability and product quality about our FDCA. And we also tried to produce one of the largest scale of PEF manufacturing in the world, which we have tried in 7,500 metric ton production facility for PET. We use that facility to produce PEF in a continuous production process as well. And yes, in 2025, we have delivered our very first commercial order for 100 metric ton of FDCA to the world. I knew that by comparison to petroleum industry, it is 100 or 200 even several thousand, 100 metric ton. This quantity is small, but for the industry of FDCA, we are kind of like delivering the very first 100 metric ton order to the world. So this is the video when we delivering the 100 ton to our clients. So you can see we are not just saying that we are doing the commercialization, but we are actually delivering the product to the world. And for the commercial plant, the total capacity for the commercial plant we have designed is for 10,000 metric ton of FDCA. But this 10,000 metric ton will be divided into 3 different phases. Phase 1 will be ready the second quarter of 2026. By that time, we will have the production capacity for FDCA about 1,500 metric ton per year, and we will reach our full capacity by first quarter of 2028. So you can see the pictures, which the tank area is already done, and the administrative buildings, they are already there. So if everything goes on well, we hope that the second quarter of 2026, we can deliver, we can successfully operate our first phase of the commercial plant. So now, later I'm going to introduce a few typical application of downstream of FDCA, because furan ring share the similar structure of benzyl ring. So theoretically, where PTA is used, we can use FDCA to replace it. But currently, we only focus on the high-value added market. For example, one is the high transparency packaging, mainly applied in cosmetic packaging. Currently, PETG is widely used in the cosmetic packaging, but CHDM is petroleum-based and is difficult to be recycled in the same system as PET, while we use FDCA to modify PET. In that way, we got modified, or we call it functional PET, which can be used in high transparency, high-end cosmetic packaging. And then second typical application for downstream of FDCA is PEF, high gas barrier packaging, because by the test data, we can see that by comparison, PEF has 15 to 20 times better gas barrier, CO2 gas barrier than PET, and is suitable for the beverage or drink or wine application, which can extend the shelf life of the product. And currently, we have been working with several big international beer companies to develop this monolayer PEF packaging or multi-layer packaging for beer application. And then the other application now we are looking at is fiber, PEF-based fiber. By Chinese standard, the material itself is 7A, which is the highest standard of 7A antibacterial, which means after 150 times washing, the material itself still acquires this antibacterial performance, which we do not add any other additives at all. So that is the most advanced performance we have seen in the PEF-based fiber, and others like anti-wrinkle, fast drying, all those make it very applicable for the application for sportswear or high-end outdoor application. And then the other is bio-based aramide fiber. Traditional aramide fiber is widely used in special industries like aerospace, fireman jacket, and all that, because the traditional aramide fiber, the textile is very hard and it's not easy to dye, so which limits this application scenario. But after we add FDCA into the aramid fiber, we see better durability and the softness has improved a lot for the aramid fiber. And actually, this is one of our first commercialized prototype, which means the 100-ton sales order coming from that direction. And yes, there are other applications of FDCA as well, polyurethane adhesive for electronic device and surfactants as well, and then 3D printing and coating as well. So basically, wherever we use benzene, in theory, we can use FDCA furan ring to replace it. So that's all from me today. If you have any questions, we have a booth over there. Thank you.